Assalamu alaikum warahmatullahi wabarakatuh. Good morning, students.
Walaikum Assalam, Mr.
Today I am going to start lecture 9, that is ER modeling. See, so far, what you studied from this lecture 3 to lecture 8 is all about what the database developer or the programmer will write the code. And now we are going to the new lecture ER modeling, where the database designers design the model of the database. So before starting the coding, uh, they will write or they will design this model. So based on model only, you are going to write the code, SQL code. Okay, so our lecture 9 title is Entity Relationship Modeling. So in this one, what are the objectives we will cover? The main components of entity relationship and the main characteristics of this uh, entity relationship will be discussed in this lecture 9. That is the first objective. The second objective is the definitions of the entity, attribute, relationship, how they have to be drawn, which symbol you have to use, okay, how you can make the connections, these things related to the design process, database designing process, you will learn from the second objective. The third objective requires to understand some clashes in order to avoid a bad design. Okay. The last one is the advanced model. We will discuss about the entity, enhanced entity relationship model, EER model we call it as. Now, first one, let us start. See, instead of these slides, I have prepared the tutorial for this lecture. It will be easier for you to understand. So I will move to that tutorial. This is the lecture 9, ER modeling. So now basically the first slide is about this one. ER model, the components are: first one is entity, next one is attribute, and the third component is relationship. So in the entity, you will learn about what is entity, how to draw the entity, what is a weak entity, those things. In attributes, key, composite key, multi-value key, and the derived key, these things. In relationships, you have already studied these things from your principles of information system: one to one, one to many to one, many to many relationship between the entities. Now move on. We will move on to the first one. What is an entity? So entity is nothing but it is pointing to a set of objects. Object like student, employee, teacher, course, book, customer, vendor. These are all entities. Okay. Before you create the table, that is called an entity here in the design. After seeing the design, when you create a table, it is called an object also, or a table, or a, yeah, table in the database. So it represents the object with some attributes, and it is drawn always with the help of this symbol. Notation is rectangle. Okay. first one. Now, what is the meaning of weak entity? Weak entity means it cannot be uniquely identified by its own attributes. That means it is depending on some other relationship or some other entity. That is why it is called weak entity. So weak entity is represented by a double rectangle like this. Okay, example, see, this is the bank account. This is an entity which you cannot be uniquely identify without knowing the bank. Suppose you have a bank account number. Suppose I say that uh, like this you have. This is what is account number, but belongs to which bank? You need to know the bank, no? Name of the bank. So that is the reason this entity bank account is depending on bank. Without bank, we cannot uh, identify this entity. So this is depending on this one. That is why to identify it is a weak entity, we have to draw it in a double rectangle. Another example like this, building and room. Can you tell me which one is a weak entity?
Room.
Yeah, room is depending on the building. This all, whatever I am telling now, it is there in your slides here. See, entity, attribute, relationships. What is the definition of entity? Weak entity, they are showing in the last, but I am explaining you now itself because it is related to entity. After that, we will discuss about this one, attributes. Okay. So this is the example, another example. So weak entity means, see, the employee has dependent. Example here, employee means, see, I am employee, I am an employee in the Seoul College of Applied Sciences. I belong to the department, so I am depending on department. Without department, I cannot uniquely identify. So if you say that Samir, you have to say that I am from IT department. So my department is IT. So that is why here the dependent is this one, department number, department name, etc. Okay, so employee is depending on this one. Either you can write this symbol or you can write this symbol. Okay, so how you can draw this symbol or this symbol is, there are online tools. There are online tools. So you can use these tools. Draw.io. The name is draw.io. The internet is slow. So here you can create a new diagram and store the diagram in a picture format or XML format, any other format. So it is free, online, and you can create your account or you may not need not to create your account. Name it something like, like this. So you can drag from here and put here, then you can add the text in this one, and you can say that here bank account, okay, another entity, you drag here and put it here. Okay, text you can put, make it like bank. Use here font style, color, bold, everything is there here, you can use. Okay, like this. You have to use this tool. That is why I am showing you in the assignment. I sent you the link in the chat box. Either you can draw like this, relationship is like this. Okay, you can make a connection or anything else. Okay, so now we will move to the next component, that is attribute. So attribute is the next component. So attribute is nothing but the characteristics of an entity. An attribute is depicted, means it is drawn or shown with the help of this diagram with notation ellipse. What is attribute? Attribute is nothing but this one: employee first name, last name, date of birth, okay, hiring date, etc. Student means you have student ID, student name, student last name, first name, middle name, age, like this. These are all the attributes. Now, in that, the different types here, this one. Key attribute means it is the one through which you can uniquely identify a tuple or a record within an entity. So it is be always with underline. See here. Can you see? Can you observe this one? Employee number is underlined. Here, employee number is underlined and department number is underlined. Why? Because it is called a key attribute. It is very important one, key. It will represent an identifying attribute. Employee number is important. With that, you can find the other details, number, age, anything. Now, next type of attribute is composite attribute. So when I say composite, it means more than one. Primary key containing more than one attribute. Example, see here. We are saying name, student name or employee name, something like that. Name may be stored as first name, last name, or your family name, like that. Another example, attribute. So attribute, address attribute. Address can also be stored as like what is your street number, Rakam al Ishara, okay. Then city, your Medina, Vilayat, Baden, Bilal. Sorry, Balad Bilal. So address can be stored with these different attributes. That is why it is called a composite attribute. Here I have written student, and these are name. Name can be divided or can be identified as first name, middle name, last name, etc. I will explain you later what is this one, and what is this one. Underlined one is the key attribute. Next one is multi-valued attribute. These are all there in your slides. Multi-valued. The name itself is telling you it may have more than one value. Example, I will say in your student, gender. Okay, gender. Attribute gender. How many values we can have for gender?
Two
Two.
value.
Yeah, male, female. So that attribute is called gender, a multi-valued attribute. So here the example of a car is given. See, car identification number, code, model code, car year, and car color, and this is drawn with two parallel lines. That means this is a multi-valued attribute. The car color can be different colors. It cannot be only one color in your car. Like see here, again this attribute is further divided into car top color. Top side you will have one color, and the front side you have one color. Body you will have one color. Top color, trim color, body color. So these are the new attributes for the multi-value attribute. This one, car color. Is it clear? Next,
Yes.
derived attribute. What is a derived attribute? Means it is the attribute whose value is calculated from the other attributes. Age, age of the student or age of the employee. We cannot directly store like you are 21 years old. That is wrong. We have to calculate the employee age based on your date of birth, Tariq al Milad. Understand?
No, Master.
Now, see how you calculate your age in the system. When you go to the student information system in the registration department, they will enter your date of birth, Tariq al Milad. So you have your date, for example, your date of birth is, for example, like this 20, 2001. Okay. And today, what date? Today is what date? Current date. Today's date. If you subtract this one, can you get the your age or not? From this, you subtract this. Can you get your age?
Yes.
Yeah, that is called calculated or derived age of a student is You are some 20 years old, or you are nearly 20 years old, something like that. This is called the derived attribute. This one. That is why it is denoted with dot 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 symbol. So we have this value. By taking this value, you have to add this one. See, directly if you enter in the system 21 years, then next year comes 2022, then you will be 22 years. Like this, we have to update everybody age. That is wrong. The system will not do like that. Automatically, the system has to calculate your age based on your date of birth. So that is known as derived attribute. So this is the second component, attribute. Now we are moving to the third component, relationship. So relationship shows you the association, the interconnection between two entities. So you can use the symbol rectangle, or sorry, not rectangle, diamond shape symbol you can use. Here you can use ellipse in the attribute. Oval or ellipse we will call. It is also called oval or ellipse. Okay, so now relationships. Some relationships are having this one, required attributes. That means the value cannot be blank. Now in your table, you are writing no. See here where it is. What is the meaning of this one? What is the meaning?
Not empty.
That means lazim read the bayanat dakhil ala attribute department name. And this one, location, I don't say it is not, that means it is optional. Mafi, lazim, no, my read this one. So optional attribute, required attribute. So this is a required attribute. This one is also required attribute, primary key. This one is a optional attribute. Optional means you may not have a value. You can left it blank. Okay. Now let us show you how to denote with a symbol. In this example of human resource, you can see in this picture, I have employee. So employee ID is a primary key, underlined one, and hash. It is denoted with symbol hash in the ER diagram. First name, I am saying that small circle, meaning optional. Asterisk, that means star, is compulsory. No, no, I think this one, yeah. This one is mandatory, and this one is the optional one. So similarly here, see ID is important, and here in the location, whereas in the country, these are all the symbols we can use for the optional and uh, what do you call, mandatory attribute. Mandatory. I have to explain you some more symbols to make sure this notation. See here, the circle, they denote it as option. We want to show you. Same example. They denote this symbol as optional, the circle. Okay, so the other symbols I will tell you later. So the circle as optional and star as a mandatory one. Okay, students, so optional attribute and required attribute. Now another one is you have domain. Domain means, as I told you, all the values, like I told for gender, male, female. Domain is a set of possible values for a given attribute. So attribute here, see, these are all called attributes. And this one is an identifier, employee ID, which is a primary key. Underlined one is called an identifier. So one or more attributes that uniquely identify each instance. That is this one. Employee ID will uniquely identify the other attributes of this entity employee. So entity, identifier, and attributes. Understand this one?
Yes, Mr.
Next, we will move to the other parts, that is relationship. So in the relationship, when you say there is a connection between the two entities, it can be shown in this example like this. There are two entities. One is called professor and the class. So professor is an entity which is related with class. So professor teaches one or many classes. So I am a professor, I am teaching you one database class or many classes. So this is a relationship, and in this relationship there are participants. Who are the participants? This is participant number one, entity professor. Participant number two, class. Entities that participate in the relationship. Who contribute or who join. Then there is a connection here. This line, connectivity, describes the relationship. What type of relationship you have? One to many. Cardinality means the minimum occurrences and the maximum occurrences with relation to the other entity. See, one professor, minimum one, maximum can teach one or four classes or many classes. These are called cardinalities, and this is a connection, type of connection. So we have to make the connection like this whenever you draw the entity relationship diagram. We are here now. Relationships. This is the slide. This one. Now there are strong relationship and weak relationship. How to draw them? How to show them? See, actually, relationship can also be represented with the help of this diamond symbol. But this normal line, if you draw like this, it is called a strong one. If I draw double diamond, then it is called a weak relationship. Can you see this one? This is the relationship between these two. Employee has many dependents, one or many. So this is a strong. If you draw this one as a double diamond box, then it is known as a weak entity relationship, weak relationship, like this. So strong relationship means what? So primary key of related entity contains the primary key of the parent entity. So this is parent, this is the related entity. Now let us see here. Example, course and class. So course is the parent and class is the child. So without course, the class cannot exist. So introduction to database course must be created first. Then only we can start the registration or create the classes for the students. So primary key of the parent table is this one, course code, CRS code, primary key. This should be included here in the class entity. So this is the primary key class section, and also it has one primary key course code, which is also a foreign key. So if you relate like this, then it is known as a strong entity, strong relationship. So there is a meaning here. Primary key of the related entity means this is the related entity. What is its primary key? This one, class section, contains a primary key component of the parent entity. So this class entity contains the primary key of the parent entity. This is the parent. So that is also there. Both primary keys are there. Then it is known as a strong relationship. So course can generate zero or many classes. One course can generate zero or many classes. These symbols you want to learn, you can go to this See here, mandatory is a star and O is optional. I told you before. I will put it here so that you will not get confused. Example. Okay. So we were talking about this one, no? Relationships and the notations. So you can refer these websites for understanding or learning what are the different notations we can use. This is one. Another one is, okay, you can also follow this one. You can learn many symbols on this one. I shared you the links. You can study later. Okay. Now strong relationship is this way. So now see the weak relationship. Weak relationship means, can you see the difference between this one and this one? This primary key is not included here in this class. That means this is a weak relationship. Weak relationship is always identified with the dotted line. Dotted line. Strong relationship means thick line, like this, the continuous line. This is a strong and this one is a weak because it is a dotted line. Why? Because the parent entity primary key is not included in the related entity. So the related entity does not contain a primary key of parent. Clear, student?
Yes.
Yes.
Now, participation of the relationship. So there is an optional, there is a partial, and there is a complete participation. Optional participation is, I told you, dashed line means this one. Partial means a solid line like this. Total participation means double lines. I will show you down. That example is there. Total means this one, like this, a double line. So total participation is this. I will explain you that. First, let us complete this. So Crowfoot symbols. So we use these symbols when we define the relationship between the entities. So it is zero or many. That means zero or many. So many side means whatever entity is coming at this side, that you have to keep it this one option. And one to many, this one, this symbol. Many side always it is mandatory. That means compulsory. The entity. This means one to one, only one to one relationship. And this one 0 to 1. So one side is optional. I will show the examples here. Now see here, this is the right side, that is the many side. So many side is optional. If you use this one, this symbol, that means many side is optional. So which side is many? This is the one side. This side is many. So this side only you have to draw this one. You should not draw here 0. Course generates zero or many classes. Mandatory relationship. See, like this symbol, if you're drawing, the class, right hand side class, mandatory class is this one. Many side is mandatory. Many means these three lines. This one. Sorry, this one. Okay, so this is the total participation. It shows that the complete college, entity college is participated in this diagram. So students study in the college. So each college must have at least one student. This symbol is total participation. And this one is partial participation. Dotted line means optional participation. Dotted line. Like this dotted line. One department can have zero or many students. Okay. Next one is cardinality. So cardinality, as I told you that uh, one or many rows from the entity are related to one or more in the another entity. So this is one to many, one to one. With these symbols also you can use. You can also use this one, or you can use this one. This is better. This one. So person has one passport. One person has single passport. Customer, one customer can place many orders. Like one customer can order for the pizza, order for the cold drink, order for the burger, order for the water, order for juice. So these are ordered. All the orders placed from are placed by one customer. Many to one. Many students study in one college. Many students are assigned to many projects. So these are the different cardinalities. And now we will move to the relationship degree. What does it? It indicates that the number of participants associated with the relationship. So in this relationship degree, one is unary relationship. Then under that it is, and one more is there called recursive. What is that? I will show you in the next slide. Then binary relationship, ternary relationship. Now I will show you with the help of a diagram. Unary. Employee is related to employee entity itself. One employee can manage zero or many employees. Example I will say, like dean of the college. Dean is also employee. We are also employees. Department head is also employee. So dean is managing all the employees, zero or many employees. Or you can say department head is an employee. He can manage zero or many employees. So this is called unary relationship. This is one of the degree. Another is binary, means two participants must be there. Two entities are associated. Ternary means three entities are associated. See here ternary in the conceptual diagram. This is called conceptual diagram. And many doctors prescribes the zero or many patients a drugs. To further enhance this diagram, we draw logical diagram. How, like this? See, one doctor writes zero or many prescriptions for one or many patients. So one or many patients will get this prescription, and this prescription contains the drug will be there, the Y. So this diagram is broken down by adding a new entity here, prescription. This is the logical design, and this is called a conceptual design. Conceptual model, logical model. Go back to your lecture 2. So these are known as the degrees of relationships: unary, binary, ternary. Now recursive relationship. Employee is married to employee itself. That means like wife is working in the college, husband is also working in the college. So husband is one employee, married to wife. Wife is also employee. Okay. Similarly, one employee manage zero or many employees. Recursive relationship. Another example, here you have course. So one course has many courses. Like when I say database, so database is like introduction to database, then advanced database design, then data analytics. Like this, you will have many data modeling, like that. Recursive relationship. Next, you have the composite entity, means uh, like this. Composite entity. See, composite entity in an entity relationship diagram. So you have a student, you have a class. How you can do the relationship? Bring one new entity which is called a composite entity: enrollment, yani registration. Student registered in zero or one classes, like this. See, classes. Class is formed in zero or many registrations, enrollments. If you read the relationship from here, one student is written in or registered in zero or many enrollments. See here, the primary key of student is placed here, student number. The primary key of class is placed here. This is an composite entity. In the assignment I have given to you, patient, doctor, that one. Now the another concept we have here is called mm, specialization and generalization. So specialization and generalization when we use is to make use of the attributes among the entities, reuse the same attributes among the entities. See, it is used to define a entity, child entity, representing uh, a specific segment of a larger entity. As I told you, mm, what do you call? Okay, department. Department is a small entity which is a part of a larger entity, what? College or university. Inside the university, you have departments. The department is a child entity, college is a large entity. So, if you want to define a department entity, we use this specialization. Generalization is opposite of specialization. Means larger entity represents the common structure of the sub-entity. So college represents department. You have many departments: IT, communication, English, general requirements, biotechnology, engineering, etc. So how we can explain to you this one? This is coming here. Existence dependence. Existence dependent, independent. Independent means a strong entity. Dependence means it's a weak entity. So it is called a strength. Now they are explaining here. I explained you this one before in the beginning of this lecture. Weak relationship means what? Strong relationship means what? I explained you here. Weak relationship, strong relationship, existence of the dependencies. So examples are same. What is weak entity? I have told you. It cannot be identified uniquely because it depends on the other entity. So it is derived from parent entity in the relationship. So examples I have shown you this one. This is a weak entity. Optional participation, mandatory also explained to you. Now I have to move. This also explained. This degree also explained. Now composite entity also I have explained just now. Additional attributes will play the connection process. This is the additional one, additional attribute. Now I have to explain to you one or two slides. See this. How do you develop the entity relationship diagram? So imagine you are the database designer or developer or analyst. Suppose Sur College of Applied Sciences called you. They ask you like they want to design a student information system. So they will call you and they will say that go and meet the registration department. They will explain you the complete operations of the college system, how we are operating. So detailed narrative explanation of the organization you have to record. So registration will explain to the developer, database developer, like every semester the student has to register 5 subjects. Okay, if his GPA is less than 2, he cannot register more than 3 subjects. If GPA is good, 2.5 or above, you can take up to 6 subjects. Every first week, we allow the students to add and drop. Next week, the after the 0th week, we will allow them to add and drop. After that, again in the 8th week, we will allow the students to drop the course. In the 14th week, we uh, calculate the 20% absentees. So these are all the rules you have to listen, you have to record, you have to write in the document. Detailed description of the operations taking place in the college. That is our organization. Now identify the rules. So as I told you rules, if your GPA is less than 2, only 3 subjects or 4 subjects. Okay, like that. So identify the rules. Then as a database analyst, you have to identify what are the entities like student, teacher, marks, course. Okay, then how these entities should be related. So these are drawn with the help of a diagram and understanding the rules of the business. Initially, you will draw the entity relationship diagram like this example. Not like this. Maybe like this. This is the initial picture. This is the initial picture for the entity relationship diagram. After that, finally, you can revise them. You can start which attribute can be act as a primary key, which one should be acted as a foreign key. These kind of attributes identification you can do in the next level of design. Again, revise it, revise and review. Then you can draw the diagram with more details like book contains what, like this ID, name, okay, address. So these are the different um, attributes you can use when you do the revision of your entity relationship diagram. See this one. Only concept means there is no attributes. Customer, product, supplier. But then, logical design. In this one, you will have these columns: name, address, gender, blah 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 blah, like this. Then, in the physical design, you will have primary key, foreign key, and also the data types. See the difference, understand it. It is very important. Conceptual design, logical design, physical design. Here you will define the keys, indexes, those things. So these are the steps, these are the way to develop an entity relationship diagram. So before you learned the DML command, DDL command, stored procedure, function, trigger, etc. Before that, you have to first draw this diagram. Based on this diagram only, if I give you this diagram, then you can start creating the tables like create table customer, create table product, create table supplier, like that. Then you can insert the data, insert into. You can update the data using update command. You can delete the data using delete command, like that. Now, design challenges, what are they? So the database design what you are drawing, it must conform to the design standards. So you should make sure it is a standard design. You should not violate any rule, business rule or the logical rules of the database. If you want the data to be accessed faster, high processing speed, more data needs to be fast uh, processed, then limit the number of relationships. Don't put many relationships between the tables. Keep the relationship simple, required one. Unnecessary relationships don't create in your design of the database. So if you want to extract more information, that will lead to the loss of speed. So you cannot get data faster if you want more information in a single attempt or in a very less amount of time. If you need to extract the data, then that will lead to some losing of the data structures. That is why keep the design simple, make the relationships which are required. Okay, don't create unnecessary relationships, like that. So these are the goals you have to remember, are the challenges you have to face while you design your database. Now, the another after ERD, people are calling it as enhanced or extended entity relationship model. So you are going to add more constructs to the original entity relationship type. Like you have an object oriented concept that you can bring in this entity relationship. So it is called enhanced entity relationship model. You are going to add more constructs. You're going to add more constructs to the concepts to the existing diagram. Then it will become enhanced entity relationship type. How, that we will discuss now, this concept. Supertype, subtypes. Entity supertype means superclass. Subtype means a subclass, entity subclass. So you know the inheritance, no? In programming fundamentals, inheritance. What is inheritance in Java? Inheritance. Inheritance is what? Tell me, what is inheritance?
The superclass
Hmm.
and subclass.
Superclass and tell me.
The parent and the child.
Yeah, child class can get the characteristics of the superclass. Example, I will say that parent class is father, child class is son. Son is having the same characteristics of the father, like the nose, eyes, ears, same shape, same resemblance. So child class inherits the parent class, like that. Now we will show this example in the next slide. I told you that specialization, generalization. So generalization, specialization, we use these terms to relate. Is a employee is a teacher. Employee is a accountant. See, I am an employee, I am a teacher. In the admin department, in the accounts department also, they are called employees. So who are they? They are also employees. So they are an accountant or somebody like that. So if you want to draw like this is an employee, for example, imagine employee is a okay. Employee is a teacher. Employee is an accountant. So like this, you can relate. This is called specialization. So specialization hierarchy is like this. So it is used to relate with the term is a. So subtypes exist within the context of supertype. So supertype is this one employee, subtype is teacher and accountant. Okay. So supertype can have many subtypes. Like this, I can have many like finance, sometimes someone else like what do you call student advisor, etc. Specialization hierarchy. So the inheritance concept is used here, and also this one subtype discriminator. So if I say employee here, one type is there, the attribute will be there here, employee type. Based on that, I can identify whether I am teacher or I am accountant or I am from finance or from admin, which department. So there is a discriminator. I will show you and explain you clearly in the next slide. And this concept also, disjoint, overlapping, complete constraints. Let us move to the next slide quickly. Show you in my this one. This one. Now see, this is the super type class. Employee. Employee number, last name, first name, initial name, hiring date means when you join, and this is the column. Employee type, which is known as subtype discriminator. You can use this one as a discriminator. That means employee is who? You are a teacher, you are a accountant, you are a finance, or who? The employee type, if I type it as value P, means you are a pilot. If I type as M, means you are mechanic. If I type A, you are accountant. So this is the discriminator. What is that column name? Employee type. And these are subtypes. These are all subtypes. One, two, three. You can have many subtypes. And these attributes are shared attributes. These attributes, since there is an inheritance here, child and parent and child classes, so child can use the parent attributes. You can see here employee number, you can use it here in this pilot class. Same attribute you can use in the mechanic class. Same you can use in the accountant. And these attributes are unique attributes to subtype. They cannot be shared among each other. This one, licenses, ratings, this one are unique. Okay, so this is the subtype discriminator, employee type, and this character like whatever you have this connection D, it is called disjoint or overlapping constraint. DRO, disjoint overlapping constraint. And this line shows that partial or complete constraints. So if I say like dotted one, it is partial. A thick line, it is showing that this is the complete constraint. That is a complete constraint. Complete or partial constraint. So subtype discriminator, I have shown you. Disjoint or overlapping constraint, complete or partial constraint. So that is all coming here. And see, this is an inheritance relationship. Employee is depending on the department. One employee may belong to zero or many departments. Or dependents, you can see here. Dependent means maybe you can also say like family, wife, children. Okay, those things. Employee has dependents. So inherited relationship, these are the shared variables, these are the unique variables, and this is the character which we store here in this column, employee type P, M, A, in order to identify the subtype. In order to identify the subtype. So this is called specialization hierarchy. So top to bottom, generalization is opposite, bottom to top. So this is what I have explained to you. So inheritance concept is there. See, lower level subtypes will inherit all the attributes from the upper level. So in one-to-one relationship will be there. So subtypes primary key is the inherited from super type, that is employee number. Employee number is the attribute inherited from this one, super type employee. Now discriminator, I told you this is the attribute which will identify or determine to which entity subtype there is a relationship. So, so if you have the value that will relate to this or this or this, the three, which one is related. So discriminator is used there. And comparing condition. If it is equal to P, pilot, equal to M, mechanic equal to A accountant. Equality comparison. So the another last concept is generalization means bottom up approach. So you have drawn here, this is specialization from top to bottom. Generalization means opposite, bottom to top. Identifies a higher level, more generic subtype from the low level. Based on grouping the subtypes, you will form the super type. So this is the complete ER modeling lecture for you. So this is basically help you to design the database. You have to design the database like this or like this. Then only you will go for this relational algebra or introduction to SQL, advanced SQL, procedural SQL, blah blah blah. All this one work will start after this design only. First design, draw the design, then you have to work on it. Any questions, any doubts? Students, I have uploaded the assignment in the Google Drive and yesterday I have shared with you. So it is very clear that what you have to do, I have written there. See, in my drive, I shared you one folder, ITDR 2106 SP assignments. It is both for both sections. When you open this, you will find your code here, section 10. For example, see Asma, Juma, Jamil, Al Badri, and Balkhis, number 3, assignment number 3. So you open this folder, number 3. There is a folder 1, 2, 3, 4. So maximum 4 choices I gave here. So number 3 you open, then you will find your assignment document here. Open that. It is clearly written here. You are going to do work on this one, university assignment. So last time you have worked on this one, this part. Now your remaining tasks are, this is the second task. You read this, you will understand what you have to do. It is there here, clearly mentioned. Function, you have to create procedure, you have to create package, you have to create and display the output like this. Then third assignment is also there here. You have to create a trigger and you have to draw the entity relationship diagram. So this is for you, for the group 3. I mean, whoever is having 3, Turaya, Juhaina, Fatma, then who is that? Swad and Basma, number 3, like that. So again, if you want this like 4, Muhammad, Rashid, and Osama. 4 means you open the fourth one, fourth folder. Go back, open the fourth here. Then you can see here the another assignment. Customer management, order management system. So assignment 1 tasks is this one, what you have done. This is assignment 2 tasks, and this is assignment 3 tasks. Is that clear, students?
Yes, Mr.
This one I have shared you to all the people. Let me share one more time. ER plus section 10 and also ITDR 210620. Okay, students. So I have shared you these links here. This will be helpful for you to draw and understand the many types of notations we can use in our diagrams. You can follow this one. Okay, so attendance. हुदा खमीज मौजूद. You are not answering. Siham,
Yes, Mr.
Muhammad Maulud,
Yes, Mr.
Sajja,
Yes, Mr.
Hajar Al-Araimi, Anwar,
Yes, Mr.
Zuraya,
Yes, Mr.
Juhaina,
Yes, Mr.
Rana,
Yes, Mr.
Fatma Al-Jafri,
Yes, Mr.
Asala Al-Baluchi, Asala, Asala मौजूद. Rashid, Jawahar,
Yes, Mr.
Yes, Mr.
okay, Zayun,
Yes, Mr.
Zainab Al-Araimi,
Yes, Mr.
Osama, Osama, where is Osama? Maybe he is in mute. Reem
Yes, Mr.
Al-Jabri, Zainab Al-Amri,
Yes, Mr.
Mariam Al-Mamari, Alia, Alia, absent. Sumaya,
Yes, Mr.
Asma, Yusra,
Yes, Mr. Yes, Mr.
Aisha, Aisha Al-Raji, Aisha, she is there. Basma, Khalud Al-Jafri,
Yes, Mr.
Balkhis,
Yes, Mr.
Fuad.
Yes, Mr.
So today Alia is absent. Alia Al-Harbi. Okay. Okay, we will see you tomorrow next class. I will close the session now. Thank you for attending.